Guys, it's Miss Linton again, coming to you on such a beautiful day to once again discuss math. It's always a beautiful day when we get to talk about math. Today, we're going to be focusing on equivalent fractions, but unlike the previous video, we're going to focus on fractions that are equivalent to a whole. Okay, or to whole numbers. You will come to realize that in other for a fraction to be equivalent to a whole, the numerator must be equal or greater than the denominators. Okay, so let's go through to see what sort of problems I have here for you today. So again, whenever we solve problems, remember, great mathematicians always read the problems multiple times. Though I am not drawing my EPA chart like we usually do in the classroom, we still need to think of the different components of problem solving. So first, you need to think of what sort of equation, if any, you will need. You'll also need to draw some sort of picture. And of course, we will need an answer sentence. We always begin with an answer sentence. That way we're getting our mind in the right frame in order to solve the problem. So let's begin. So Owen Cash calls to order 3 pizzas from the Automatic Pizza Company for his party. He asks that they cut all the pizzas into halves. How could we write the number 3 as a fraction to find out how many halves Owen's pizzas were cut into? Okay, so again, I'm going to reread the question, and at that time, I'm going to highlight the key pieces of information necessary for solving the problem. So Owen Cash calls to order 3 pizzas. So we know he wants a total of 3 pizzas. So I'm going to highlight that, okay? 3 pizzas from the Automatic Pizza Company for his party. He asked that they cut the pizzas into halves, okay? So again, that is something that is important. They need to be in halves. So again, I'm highlighting that. Then it goes on to say, how could we write the number 3, okay, 3 being a whole number, how could we write the number 3 as a fraction to find out how many halves Owen's pizzas were cut into? The question is something I'm going to highlight again. That way I can write my answer sentence, okay? So we're trying to find out how could we write the number 3, which is a whole number, how could we write that as a fraction to find how many halves Owen's pizzas were cut into? So I'm going to document Owen's, so my answer sentence, ANS, okay? So Owen's pizzas were cut into blank, okay? Let me just make it a little bigger so it's easier for you guys to see, okay? So I have my answer sentence. Do I need an equation in this case? Not necessarily, okay? But then I'm going to go through and I'm going to cut each pizza into half. So remember, if it's in halves, there are 2 equal parts, okay? So both parts are equal, 2 equal parts for each pizza, okay? So each pizza is now being cut into halves. We need to know how many halves Owen is going to receive. So all we need to do, now that we have cut each of the pizzas into 2 equal parts, we're just going to simply count 1, 2, 3, 4, 5, 6 halves. So 1 half, 2 halves, 3 halves, 4 halves, 5 halves, and 6 halves. So Owen's pizzas were cut into 6 halves. Okay, so 6 in this case is our numerator. That's the total number of pieces. And then 2 signifies our denominator, which is the number of pieces in a whole. So 6 halves is the same as 3 wholes. Pay attention to this number, 6 halves. and pay attention. See how it relates to 3 wholes. So I'm just going to write this as well. Well, type 3 is equal to 6 halves. Okay, and think about that. There is a connection with multiplication and division. Think about that. I'll talk about it towards the end. So there you have it. Pretty simple, pretty straightforward. Okay, so let's look at the next problem. So after sitting and thinking for a while, Owen Cash decided that he should have invited a few more friends to the party. He contacted the Automata Pizza Company and requested that his pizzas be cut into fourths instead. How many fourths would Owen receive should he keep his order as 3 pizzas? So when we think of fourths, remember previously we said when the denominator increases, the pieces, they become smaller. So in this case, it's now being cut into fourths, which means he should be able to feed a whole lot more individuals than previously. So previously, we know that he could only serve 6 individuals, because there were 6 halves in the 3 whole pizzas. In this case, we're going to cut it not in halves, but in 4. So each whole will have 4 parts, 4 equal parts. So he should be able to serve a lot more people. Okay, so let's reread the problem again, and this time pull out the key pieces of information. So after sitting and thinking for a while, Owen Cash decided that he should have invited a few more friends to the party. Do we need anything here for the problem? No, it doesn't really matter. Okay, none of that information. He contacted the Automata Pizza Company and requested that his pizza be cut into fourths. So fourths tells us that he's cutting it into 4 equal parts. Each whole has 4 equal parts. Okay, so instead of doing halves, which was 2 equal parts, it's now 4 equal parts. Fourths. So your denominator would be 4. So the question asks, how many fourths would Owen receive should he keep his order as 3 pizzas? So did his number of wholes change? No. Okay, he still has 3 wholes. Okay, however, he's cutting it into fourths, which means it's going to be smaller pieces than previously, which means he's going to have a lot more pieces. Okay, so I'm going to document my answer sentence. Okay, so the question is, how many fourths would Owen receive should he keep his order as 3 pizzas? So in this case, our answer sentence, and this is way too big. Okay, so let's make it a little smaller. Now this is too tiny. Just bear with me. Okay, so in this case, Owen would receive blank. Okay, and then just let's bring it up a bit. Okay, so Owen will receive, why did I type blank? Would receive blank. Okay, so again, how many pieces did we say each pizza is going to be cut into? It indicates fourths. That's correct. 4 equal parts. Okay, so here we go. So here we have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4. Okay, so in this case, Owen would receive 12/4. Okay, so again, so previously I said, okay, notice there is a relationship. So we know that 3 wholes is equal to 12/4. Okay, so I said there is a relationship between the whole number and the fraction, thinking of multiplication and division. Okay, so when we look at the number 12, and I believe some of us made that connection in class previously between division and fractions. Okay, because we know that division is putting it into equal groups. And here with fractions, we are breaking it up, or we are splitting it, or we are decomposing it, or dividing it again into equal parts. So if we have 12 as our numerator, and we have 4 as our denominator, think of it. 12 divided by 4 equal parts gives us what? 1, 2, 3. You see the connection? You see it? Okay. So it's exactly the same as division. Okay. We could have said, we know we have 3 whole pizzas. Each pizza has 4 parts. We could have said 3 wholes times 4 parts would give us 12 parts. And this is what our numerator is. Okay, so that's just another way to look at it. Okay, so hopefully you have gotten that. Let's look at it in the reverse. Okay, so we have a question here. What whole number can be written as 18/6? Draw a model to help you. So think of it. So we are now looking for a whole number, not a fraction, a whole number. So we are looking for a whole number that is the same as 18/6. Okay? So let's look. What can I draw? Okay, so I know a hexagon has 6 sides, and my denominator here tells me there are 6 equal parts. So just for to make life easier, I'm going to draw hexagons. Okay. So I'm trying to get 18 parts that are 18/6. Okay. Let me just bear with me. Okay. So in one hexagon, I'm going to have 6. I'm trying to get 18. So I'm going to need multiple hexagons. Okay. So thinking of the multiplication and division I said to you earlier. So 18 divided by 6, what does that give us? 6 times what would give us 18? Awesome, awesome job. Okay, give yourself a thumbs up. So 6 times 3 is 18. So that's correct. We would need 6 hexagons. Okay, and I'm going to decompose it or divide it into my 6 equal parts. So that takes a little while with the computer. So just bear with me. 1, 2, 3, 4, 5, 6. And you know, if we were doing this on paper, we would be done with it a long time ago. So I'm trying to get Just bear with me one sec. So let's look at each figure now. So I've cut it all into 6 equal parts, okay? So 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, okay? So that's 6 6, okay? Then moving along, I have a second figure with 6 6, and then a third with 6 6, okay? So if I count it all up together, okay? So 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6, 8 6, 9 6, 10 6, 11 6, 2 6, 12 6, sorry. Miss Linton is going backwards. 12 6, 13 6, 14 6, 15 6, 16 6, 17 6, 18 6. So 3 wholes, okay, is equal to 18 6. And notice that 3 times 6, 6, 6, 6. Each have a 6. So 3, okay, 3 times 6, 6 gives us 18 6, okay? So in each we have 6 6. Got it? So there you have it, okay? I added an additional slide. That way you can just try it on your own. Again, if you have any additional questions with reference to that, feel free to ask myself or any one of the third grade teachers, okay? And we'll be more than happy to assist you. Most likely, I'll add it to Google Drive, Google Classroom. That way you can submit your answer there and I can give you feedback. So the 2 questions I added was using the model below, write a fraction equivalent to 4. And in this case, 4 is a whole number. So you're to use the model and you're going to write a fraction that is equivalent to 4 wholes, okay? Then the second thing you're going to do is you're going to draw a model to show 6 ones, okay? 6 1 or 6 wholes, okay? So what is the big idea here? What is it we have spoken about? When we started, I said we're going to be talking about equivalent fractions, and we will look in today at equivalent fractions that are equivalent to whole numbers, okay? So when determining fractions equivalent to whole numbers, we need to think of the number of parts, okay? Again, remember, when we talk about the number of parts, we are talking about the numerator. Then we have to think of the number of parts in the whole, okay? Remember, when in the classroom, numerator, denominator, parts in the whole, numerator, denominator, parts in the whole, okay? So we have to think of both the numerator and the denominator. Then you're going to draw a picture to help you, okay? And remember, in the case of fractions that are equivalent to a whole number, the numerator is always equal to or greater than the denominator, okay? In years to come, you will learn that these are actually called improper fractions, okay? So here you have it. As always, feel free to reach out to any one of us, as I said, if you have any questions, that way we can assist you. Hopefully this lesson here will be able to help you with the assignments listed in the May 4th to 8th of your package, okay? Have a wonderful day, and I hope to see you soon. Take care. Bye-bye.